Let's take a look at the Unit 1 exam review. Just a friendly reminder, retakes are not allowed on unit exams, so it's a great idea to take every opportunity you can to get enough practice in before the actual exam. Number 1, is air considered matter? Well, let's think about what air is. Air is made of mostly nitrogen gas, but it's also other gases like oxygen and argon, carbon dioxide. So, is this matter? Yes, because it has mass. You could blow up a balloon and see that it weighs more after, and it takes up space. So by definition, it fits to a T. Number 2, which of the following is the best answer for the correct measurement below, where the arrow is? So we've got 0, 5, 10, 15, 20. So if we were filling these in, it'd be 1, 2, 3, 4. And it's definitely a little bit closer to the 5 than the 4. But we can't say something like 4.700. That's too precise for what this tool is allowing us to do. Since the tool goes by the ones place, 4 to 5 to 6, we are only allowed to estimate out one digit more. So the best answer would be 4.7 centimeters. Density. As a little reminder, density is a property about matter, and it has to do with the way things are packed. So you could have two equal-sized boxes, and in one box you could have something that wasn't very packed, and in the other box you could have more mass per volume, and so we would say that that one is more dense. So you can see that different materials like gold and silver have a very high density when compared to something like aluminum. So number 3 asks, what is the density of a substance? Formula is mass divided by volume. If the mass is 232 grams and the volume is 25.8 milliliters. Punch that into a calculator and it comes out to be 8.99 grams per milliliter. So what metal does that match up with? Well, it looks pretty darn close to copper. So this material must be copper because copper is always packed the same way, about 9 grams per milliliter. Number 4, what is the volume of a 30-gram sample of gold? How much space would it take up? Well, if we want to know the volume, we can cover it up and we can see that that's mass divided by density. So 30 grams divided by the density of gold, which is up here in our chart, 19.3 grams per milliliter. 30 divided by 19.3 is 1.55 milliliters. You could also set this up using dimensional analysis if that's going well for you. You would say 19.3 grams equals 1 milliliter. Multiply across the top, divide by the bottom, you get the same answer. Describe the function of a graduated cylinder. That's one of these guys. And you put a liquid in it. So its function is to accurately measure the volume of a liquid in milliliters. Number 6, describe what it means for something to be labeled AQ. AQ means aqueous, and that means a substance dissolved in water. So it might look like a clear solution, it might be blue, but there's definitely something dissolved in that water. And that's different from something that's just labeled a liquid. A lot of times this is something that is melted. So for example, an aqueous sugar solution would just be sugar dissolved in water. But liquid sugar is sugar that's been heated until it reaches its melting point and turned into a liquid. Number 7 is some simple element symbol review. You can't forget your elements. Potassium, mercury, lead, tin. Determine the number of elements and atoms in this compound, Na2CO3. So we've got 2 Na, which is sodium. We've got 1 carbon, and we've got 3 oxygen. Number 9, name one element that will have properties similar to cesium. You have to check out your periodic table, and on the periodic table, cesium is number 55. It's in group 1A. So you can choose anything that's in group 1A. So above it, below it, you could choose something like lithium, sodium, potassium, rubidium, or francium. All are alkali metals in this case. So they all have one valence electron in group 1A, and so they all have similar properties. Number 10, identify one element which belongs to each of the following families. So you need to look at your periodic table right now. The alkali metals are in group 1A. So the question number 9 was about this, so we can choose one of those. The noble gases are on the far right. They're group 8A. So something like neon. Transition metals are that whole middle block of the periodic table, also known as group B. So copper is in there. The halogens are group 7A. So fluorine is one of those. And the alkaline earth metals are in group 2A. So something like magnesium or beryllium, anything from group 2A. And then number 11, identify these as metals or nonmetals. Remember the periodic table has that zigzag? Everything to the left of the zigzag besides hydrogen is a metal, and everything to the right is a nonmetal, and the ones that border the staircase are the metalloids. So chromium is to the left of the zigzag, so that's a metal. Oxygen is to the right, so that's a nonmetal. Tin is to the left. Lithium is to the left. And neon is to the right of the zigzag. Investigation 3. Describe the most current model of the atom and draw a picture below. What's one thing your model illustrates well and something it doesn't do a good job illustrating? So the most current model is the electron cloud model. And in this model, electrons are in regions of probability called clouds. So in the nucleus, we've got protons and neutrons. And then you can shade a cloud. It's a little bit more dense usually toward the nucleus, and it gets more and more sparse. So let's label in the nucleus the positive protons, the neutrons, and then the electron cloud. Electrons have a negative charge. What's one thing it illustrates well? It shows We'll write a plus. It shows a nucleus at the center. Something it doesn't illustrate well, it's a stagnant picture, so nothing's moving, which is not true. A nucleus would actually be vibrating and the electrons would be moving like crazy. Also, the scale is not appropriate. The nucleus is very, very tiny compared to the electron cloud. Remember that analogy of a baseball stadium? You'd have to put a P in the center of the field, and that would be the nucleus, and the entire stadium would be the electron cloud. Atoms are mostly empty space. Number 13, when you heat up a sample of helium gas and observe it through a spectroscope, you see multiple bands of light of different colors, including red and blue. What's happening inside the atom that causes this? Include a diagram. So helium has 2 electrons in shell number 1, and then remember there are all these empty shells surrounding. And what happens when you run electricity through that gas is that electrons jump up to a higher shell, and eventually, because that's not stable, they fall back down, releasing a wavelength of light. A low energy jump would result in a long wavelength, and this would produce a color like red. But thanks to the distances and some electrons getting more energy, they can make larger jumps as well, and that fall will result in a higher energy wavelength of light, and so this would be a blue color. Number 14, what's the total number of electrons, assuming it's neutral, the number of valence electrons, and the number of core electrons for these? So silicon is number 14, and it's in group 4A. That means it's got 14 total electrons, and that means that 4 are valence electrons, because that always matches the group number. So if there's 14 and 4 are in the outermost ring, how many are left in the core? You do 14 minus 4, that means there are 10 core electrons for silicon. Arsenic is number 33, and it's in group 5A. That means it's got 33 total electrons, and that means 5 are in the valence shell. So 33 minus 5, that's 28 core electrons. Selenium's right next door. It's number 34 in group 6A. That means it's got 34 total electrons, 6 valence electrons, which ends up being the same number of core electrons. Number 15, answer the following questions for an atom with atomic number 80. Well, that's Hg if you look it up. That's mercury. How many protons does it have? Since it's number 80, it's got 80 protons. How many neutrons would it likely have? At the bottom of its periodic table square, it says the average atomic mass is 200.6. If we round that to the nearest whole number, that's 201 minus 80 protons. That leaves 121 neutrons in the nucleus. Because remember, protons plus neutrons make up that mass number. How many electrons would it have if it's neutral? Well, since it's number 80, it will also have 80 electrons. Remember, the positives cancel out the negative electrons. How many valence electrons would it have? This one's tricky. All the transition metals have 2 valence electrons. So 80 minus 2, that's 78 core electrons. Name another element that has properties similar. Well, if you check out where number 80 is, cadmium, Cd, is right above it, and Zn, zinc. It would definitely be a metal because it's to the left of the zigzag. Number 16, an atom of magnesium which has 14 neutrons would have what mass? Well, since magnesium is number 12, that means it's got 12 protons. So if it's got 14 neutrons, that adds to a mass of 26. And the way to write a symbol is mass number in the upper left and atomic number in the lower left. Following that pattern there, what's the isotope notation for an atom with 11 protons, 12 neutrons? 11 plus 12 is 23. 11 protons, if you look it up, sodium is that element. Uranium's got 3 common isotopes. So it's 234.01% of the time. So if we move the decimal 2 back, 0.01, there's 3 zeros, plus the next average mass times how often it occurs, how popular it is with the decimal moved back, plus the next average mass, 238, times, this is the most popular one, so we expect that the average is going to be pretty darn close to 238. And I punched this in, it came out to 237.98 grams per mole, or AMU. You can use either units there. Number 19, list the following atoms in order of increasing size. So let's look at where these are. On the periodic table, it's fluorine in period 2, and then right below it is chlorine, and then right below that is bromine, and then just to the left of chlorine is sulfur. So we've got period 2, 3, and 4. Automatically we know that fluorine is the smallest because it only has 2 shells in period 2. Then we have to decide between sulfur and chlorine. Both have 3 shells, but chlorine has more protons. So that means that those positive protons in the center are going to be pulling in, attracting those shells a little bit tighter than sulfur. So chlorine would be the next smallest, the next largest, and then a little bit larger is sulfur, and the largest one is bromine because it's in the 4th period, so it has 4 shells. All right, what happens to the mass number and atomic number in an alpha decay? Remember, alpha decay has a chunk the size of a helium nucleus that's leaving the nucleus. So the mass goes down by 4 when that happens, and the atomic number goes down by 2. In beta decay, a high energy electron that was once a part of a neutron leaves. So now the neutron changes into a proton. So the mass doesn't change. Mass has no change. But the atomic number goes up by 1. So let's practice. How about the beta decay of gold? 201. Gold is number 79. And when one of its neutrons changes into a proton, the mass stays the same, but that atomic number goes up by 1. It's a new element now, so you have to go to your periodic table and look up what it became. In this case, it became mercury. How about platinum 192 undergoing alpha decay? Platinum is number 78 on the periodic table, and so when this nucleus loses a chunk of itself, Now it only weighs 188, and it only has 76 protons. So that means it became element osmium, OS. Now fusion is different because the plus side is to the left of the arrow. So if we've got helium-4 and neon-20, neon's number 10, and those two nucleuses fuse together to make one big nucleus, it's going to become a magnesium. You have to look up number 12 on the periodic table to figure out what element symbol to write. What's the difference between a chemical and a nuclear equation? In a chemical equation, or a chemical reaction, this is a rearrangement of entire atoms. Atoms move around. But in a nuclear reaction, this is a rearrangement of protons and neutrons within the nucleus of the atom. That's why we can't do those in the classroom, because that's pretty dangerous to rearrange the nucleus of atoms. Compare and contrast nuclear fission and nuclear fusion. Well, they both release a lot of energy, but they do it in different ways. In fission, a heavy nucleus is split. It's kind of like bowling. They throw something small at it and it just explodes apart. But in fusion, two small nuclei combine. Fission is what they do in nuclear power plants right now with uranium atoms, and fusion is what's happening in the sun. Hydrogen atoms are fusing to produce helium. Thallium-208 has a half-life of 3 minutes. So how long is it going to take 120 grams to decay to 7.5 grams? Well, after 3 minutes, there's only 60 grams left. After another 3 minutes, there's only 30 grams left. After another 3 minutes, there's only 15 grams. And after another 3 minutes, there's only 7.5 grams. It keeps cutting in half. So how long did that take in total? That comes out to be 12 minutes for your final answer. A chunk of potassium has a mass of 700 grams. Always start by writing what you know. How many moles is this? Well, you have to go to the periodic table and look at potassium square. Potassium has an average atomic mass of 39.1 grams for every 1 mole. So how many moles do we have if we have 700 grams? Well, let's set this up. 1 mole of potassium is equal to 39.1 grams. So then we multiply across the top and divide by the bottom to figure our answer out. And in this case, it comes out to be 17.9 moles of potassium. How about number 2? It says we've got a sample of iodine and a sample of copper that have the same number of moles. So what if the copper has a mass of 127 grams? Then what must be the mass of the iodine sample? Similar to last time, we need to look up the molar mass of copper on the periodic table. It says that it's 63.55 grams. That means after you multiply across the top and divide by the bottom, that you've got 2 moles of copper. So this problem said you have the same number of moles of iodine. So how much would that weigh? So now we need to get moles of iodine into grams. So I need to write moles on the bottom so that these will cancel out. 1 mole of iodine, according to the periodic table, weighs 126.9 grams. Times 2, 253.8 grams of iodine. How much would 3.5 moles of nickel weigh? Well, the next question you should ask yourself is, how much does 1 mole of nickel weigh? What is that conversion unit? And according to the periodic table, it weighs 58.69 grams. So if you had 3.5 moles, you've got more than that. Multiply across the top, it comes out to be 205.4 grams of nickel. Which would contain more, 10 grams of copper or 10 grams of carbon? Well, copper has a molar mass of 63.55 grams per mole. Carbon is only 12.01 grams per mole. So carbon is smaller. So that means that if you had 10 grams of each, you've got more atoms of carbon, because it takes more carbon atoms to get to 10 grams. Carbon is smaller, so it takes more atoms of carbon to have 10 grams. Number 5, what is this element? Well, we need to know grams per mole, because that's what the periodic table has units in. So 104.12 grams for 15 moles. Let's divide that out. That comes out to be 6.94 grams per mole, and that matches lithium on the periodic table. All right, you want to mass out 0.1 moles of copper sulfate, CuSO4. How much is this going to be in grams? Well, how much does 1 mole of CuSO4 weigh? You need to go off to the side and figure out the molar mass of each of these. So you need to get a periodic table and look up copper's molar mass, 63.55. Sulfur is 32.07. Oxygen is 16, but there's 4. So you have to add up all of that. It ends up adding to 159.62 grams. That's how much 1 mole weighs. What if you only need 0.1 moles? You need to multiply across the top, divide by the bottom. It comes out to be 15.96 grams of CuSO4. Student dumps 123 grams of HCl into some water. How many moles is this? Well, how much does 1 mole of HCl weigh? Again, go to your periodic table and add up the molar masses for each of those elements. The molar mass comes out to be 36.458 grams. Multiply across the top, divide by the bottom, and you get 3.37 moles of HCl. And the last question is just annoying. It's a big molar mass of TNT, 7 carbons, so 7 times carbon's molar mass, plus 5 hydrogens, check the periodic table for hydrogen's molar mass, plus 3 nitrogens, nitrogen's molar mass, plus 6 times oxygen's molar mass, and you add all that up, and it came out to be 227.14 grams per mole. Another great thing to study is the set of objectives for Unit 1, which is also in your OneNote folder.